Hi everyone, we are Team Surgical Mass and our final year project is Neural Spell Checker. This is our team, Akesh, Tarusha, Nadil and our supervisors, Dr. Nisansa and Dr. Surangika. Let me give you a brief introduction into spell checking. Spell correction is the process of identifying and correcting misspelled words in a text. Spell correction mainly consists of two different steps, error detection and error correction. A spell correction solution must perform both of these steps relatively well to consider that as a successful solution. Let me walk you through the pre-training frameworks that we used for our project. We use pre-trained language models of these three different architectures. The first one, the decode-only architecture, the encode-only architecture, and then the encoder-decoder architecture. These are the different models that we used for our final year project. As you can see, we have used MT5, MBART50, XLM Roberta, Sinbird, Llama 3.1, and Gemma 2 models. You can see that these 6 models span across the different architectures that I showed you before. This is an empirical study that we did for Sinhala spell correction. As here you can see, the encode-only models, Sinbird and XLMR, are not the best performing models out of the 6 models. You can see that MBART 50 and MT5 models have comparatively high results, and also you can see that the Llama 3.1 and Gemma 2 models have the best results out of the 6 models, which goes to solidify that decode-only models can perform very well when there is enough data to train those models. We also conducted experiments on different languages to see the performance of the different model architectures across those languages. As you can see, we have conducted experiments for these languages, and you can see the results for detection on the top table and for correction in the bottom table. We have limited the number of sentences in the training set to 5,000 to be for this experiment to be comparable across the languages. As you can see, the Gemma 2 model performs much better for French and Hindi, which are high resource languages, than the other models. But Gemma 2 model does not natively support the two languages, which goes to show with the right amount of data, the decode-only models can outperform the other models, even though those models natively support the language. We also made some improvements to the existing architectures for single spell correction. We have included all of those improvements into a toolkit that we created, and we will take you through that toolkit from now.
LMSpell offers three core products: a versatile library for developers, a user-friendly web app, and also a browser extension. With our library, anyone can easily build advanced spell checkers using state-of-the-art pre-trained language models. We've abstracted the complex processes behind spell checking, making it incredibly simple and intuitive to use. As here you can see, first you have to import our library and then create a model instance for any pre-trained language model that you like. Then you can create a trainer instance for that specific architecture of pre-trained language model. This is a sequence to sequence trainer because it is an MT5 model. And then you can just train that model using the trainer. And then to test the model, you can just call model instance.correct. And you can give two texts that you need to correct and also the ground standard and also an output directory to save your results. You can also test your model using a file. It could be a text file or a CSV file, and you can just call model instance.correct.from file, and you can give the location of the file to the function, and it will correct that text in the file and also save the results in the output directory that you provide. Through extensive optimizations, we've also reduced both training and inferencing times, making the toolkit efficient and practical for real-world use. Our library will be publicly released following acceptance of our paper at the top-tier EMNLP 2025 conference. For our mother tongue, which is Sinhala, we've gone a step further and we've developed both a dedicated web app and an extension for spell checking. The web app allows users to use a model which is MT5 and use it for accurate and real-time spell checking of their text. As here you can see, this is a text that I have entered to the web app, and you can correct it and the results will appear here. As here you can see, in the first text, the word Aramba is not an erroneous word in itself, but in this context, that word is erroneous. So the model has identified that and corrected it to the correct form of that word. This is an example of contextual error correction, which these pre-trained language models are capable of. Previous approaches like rule-based methods were not able to correct these contextual errors. Our browser extension seamlessly integrates with any website and automatically detecting Sinhala spelling errors as you type. It highlights the mistakes like you can see and offers instant correction suggestions. As you can see, the word Aramba, as I told you before, is contextually wrong. Therefore, the extension gives this suggestion for you to change that word. You can click it and the checks will be changed to the correct form. Best of all LLM products are freely available for public use. Our mission is to empower everyone, especially those working with low resource languages like Sinhala. Thank you for your interest in LLM Spell.